Now for this next screencast, we're going to look into the third and final area of work and how to calculate work. And so just another reminder, as I mentioned in the previous screencast, there are three main areas that the quiz will focus on. The first one is on mechanical advantage, and the screencasts that were posted last week. The second main area is on calculating force and a few definitions, and those main concepts were reviewed in the previous screencast. And the third and final screencast you'll use to help you to study for the quiz is this last one, which is focused on work. And so, as I mentioned before, definitely use these screencasts to help you, but also be aware that you should be studying the pages in your textbooks as well as the class notes and class examples that we've gone through in class. Okay, and now in case you want to follow along in your textbook, the pages that have this information, I'm just going to write it over here, is page 106 is one of the pages with this information, but the page that has a lot more other information is page 110. So for this section, it's just 2 pages. Okay, we're going to look into work. And now, what is work? It's not going to work, as in, I'm a teacher, so I work as a teacher, but there's a very specific scientific definition of work. And that is the definition we're going to use for this review session. So, the scientific definition of work is the amount of effort or energy, you can think of it that way, the amount of energy spent when a force causes an object to move a distance. Now, this is important. Let's make it a little better, if the object actually doesn't move at all, that means no work is done. Okay, so let me write that down. If there's no distance, that equals no work. Okay, and the example, the example I gave in class was if I spend a lot of effort or a lot of energy trying to hold up a poster against the wall. Okay? I am definitely expending effort or using energy, but is the poster actually moving? It's not. It's actually just held up against the wall. So by this scientific definition of work, I'm actually not working. Okay? It's a very important definition or very important concept to understand. Now let's get straight to the formula. The formula is W equals FD. Let me put that in a box here. This is the major formula. Should be focusing on W equals FD. And let's try and label what each of these are. Okay. So W stands for work, and it's measured in joules. Short form is J. Okay. F is force, and actually, interestingly, same force from the formula we used earlier. The same thing as F equals Mg. Okay, and this is also measured in, let me just draw an arrow, newtons. And the last one is, you can probably guess it, it's distance. And it's measured in meters, okay? So if a question gives you a distance in centimeters or millimeters, make sure you do the conversion so that distance is measured in meters. Now let's just go straight to a few examples, because that will probably be the most helpful. So let's use example number 1. Okay, let's say you push a box, and let's say your force is, let's say, 50 newtons, and let's say the box moves, let's say it moves 3 meters. Actually, let's switch it up. Let's say this box moves 300 centimeters. Okay. Now, you want to calculate, so let's say find work, or find work done. Okay. So let's do that. Let's use our formula. We have W equals to FD, or work is equal, let me make that a little clearer. Work is equal to the force times the distance. Now, what is the force? Force is 50 newtons. Okay, let's check the units. There's a newtons here, That's good. And it's also measured in newtons right here, which is good. The box moves a distance of 30 centimeters. Now this is a problem for us because this is centimeters, but the formula asks for meters. So we should do that conversion. What is 300 centimeters in meters? Well, do that conversion, it's actually 3 meters. Then you can plug this in. What is the work done? 150 joules, and you are done. Okay. Let's go to another example. Let's do it over here. Actually, let me use space for the third one. Okay, let's do it over here a little bit closer. Let's use green. Example number 2. Okay. Now let's say 1320 joules of work is done. Okay. And let's expand it more. Send to move a bike. Oh. Let's say this bike moves 12 meters. Let me see. What is a force? What's force applied? Okay, so let's write down the formula. W equals FD. Now I know that this time this is the amount of work done. So let's plug that in for W. That's the amount of work done. I'm trying to find the force applied, so I don't know what that is. But do I know the distance? The bike moves 12 meters. Okay, so F times 12. So using a little bit of algebra, if I have 1320 divided by 12, what do I end up with? Let me just do that on my calculator. Let me screen that up. Here we go, calculator. I've got 1320 divided by 12 is 110. And what is the units? Since it's force, it's measured in newtons. Okay. Now let's go to our very last example. Let's go back to yellow here. In this one, I saved a little bit of space for it because it's a little bit longer. Let me write this one out in full. Okay. I'll write out. Here we go. The box. Okay, so here's a question. A box has a mass of 32 kilograms. It must be moved 12 meters. How much energy is needed? Now you can see here I can definitely find ways to kind of adjust how I ask you the question here. Now this keyword of energy, for the purposes of our quiz, think of it as same as work, okay? So instead of asking how much energy is needed, you could say how much work is needed or how much work would be done with it, okay? So hopefully with this piece of information, we can start some calculations, okay? So I'm going to start on this side here. So it asks for how much energy, how much work is done. So let's write down that formula. W equals FD, okay? Now I know I need to find how much energy is done, so I don't know the W. Then it also says, wait, I don't know the force here, so that might be a little bit of a problem. Now it says it must move 12 meters, so at least I have that. Now I cannot find how much work is done because I don't know the force. But this is an example where I'm linking the formula from this screencast to the one from before. Can I find the force here? And the answer is yes, I definitely can. So I have another formula for force, F equals mg. Now, do I know the mass of the box? Yeah, it's right here. It is 32. Now, gravity, okay? We're going to make the assumption here. It doesn't say you're in space. It doesn't say you're on Mars. So we're going to make the assumption that this is on Earth. So the force of gravity on Earth is 9.8. So let's actually find the force here. So I'm going to go to my calculator. It's already open. Move it here. Let's do 32 times 9.8. And that gives me 313, let's see, 0.6. Now I can plug this number for force into my formula. Let's go back to my trusty yellow. And what I have is, okay, force is 313.6 times 12. And that will give me how much energy or how much work is needed. So let's do that. Got 316.6. Let's do times 12. And I get 3763.2. 3763.2 here. And what is a units for work or for energy? It's measured in joules. And now I am done. So hopefully these series of screencasts will help you to prepare for the quiz. In the lessons this week, you will have a chance to work on your labs. You'll also have a chance to practice a lot of questions for your quiz. Okay? And all the best as you study. And I'll see you guys in class.